So this is going to be about section 7.1, polynomial functions, nonlinear functions, and we're going to go through all the pictures of them today. So the first one is absolute value, and it goes up like a v or down like a v if it has a negative in front. The second one is quadratic. It curls up or curls down. I call these changes in direction. So this has one change in direction, positive, negative, opens up, opens down. Next we have cubic, two changes in direction, and it goes like this. Notice the degree is 3. The degree is the highest exponent. And then a -1, it ends to the bottom. When it's negative in front, it ends going down. Quartic has a 4 up here, and it goes and ends up because the front term is positive. And this one would be a negative quartic because this one would be a negative here, and it ends down. We have a lot of graphs to go through. So let's talk about sine. Sine and cosine and tangent. The graph of sine of x goes through 0, 0. The graph of cosine does not. That's how I delineate between the two. Tangent. This one's rational. These are rational functions. We'll just call these rational graphs. Notice how x cannot be 0, so it jumps from 0. It doesn't touch 0, but it jumps. Exponentials grow, just like compound interest, or it goes down if it's negative, or if the exponent itself is negative, it goes down at a streak, but almost always touch it, goes down and just rides that line without touching it. Next is square roots. They grow, and negative square roots. Step functions look like little steps, and they have these little brackets around the x. And piecewise are literally pieces of lines, 3 pieces of lines. So that is where we start, and you have to know this. Going forward, you are going to have to, section 7.2, graph polynomial functions. So matching is what that whole section was. You need to be able to match every graph. And the second thing, even more important, is you're going to have to sketch all the time. And there are 3 things you need to know if you're going to sketch. 3 things you must know. You must know. So the first thing is degree. And I'll get to the other 2 later. That's how important the first one is. A degree is the largest exponent. So if you look at these, we have exponent of 2, 1, and no exponent. So this one, the degree is 2. This one, exponent is 2, 3, and 5. The degree is 5, even though they're not in descending order the way they should be. So you need to know what a degree is. Why is a degree important? Because the degree -1 is the number of changes in direction. And it goes the other way too. So if I have this example here, y equals x to the third plus 9x plus 1. The degree is 3, but the changes in direction are 2. Let's apply that to a graph. You should be able to go the other way around. So if I give you this graph right here, the green graph, how many changes in direction are there? 2. But what is the degree? Don't look at the answer. Yeah, it's 3. So you need to be able to go from the graph to the degree, and from the degree to the graph. So let's try this one right here. I'm going to cover it up. So how many changes in directions are there? 1, 2, 3, 4. So the answer is 4. What is the degree? Now remember, the changes in direction is the degree -1. So just add 1 and you get a 5. And that's the answer. And now you're going to have to apply this to other shapes. You're actually going to have to do this when you're just given pictures. So if I give you the picture, this has 2 changes in direction, you have to tell me this is a degree of 3. If this one here, this is going to be your matching homework. But this one here, just looking at this, 1, 2, 3 changes in direction, the degree is 4. This one, the degree is 6 with a change in direction that equals to 5. Make sure you know these going forward.